look at those and prepare yourself for what's to come. And I've went ahead and decided that I'm going to give you guys Thursday and the Friday. So what that means is Thursday at 12:01 a.m., so at midnight really, it's going to open. Midnight on Wednesday, I suppose. It's going to open, and you're going to have all of Thursday up until 11:59 p.m. on Friday. Now, having said that, when you open your exam, you do have to take it in one sitting. So it's not like you have 2 days to, write the problems down, go do the problems, come back and type them in. You just have 2 days to complete it, meaning once you start it, you have 2 days in which to actually start and then finish. And of course, it's going to be the same as the last one. It'll be presented to you in Hawks, and you will complete it by typing in the answers. And additionally, you will be writing your answers down, on paper like you have been. And then you will scan those papers into me, and you will submit it on the Dropbox on Blackboard. And then I'll spend some time grading them and releasing them out to you. So before we continue with our notes, are there any questions on the process of the exam? Anybody have anything they want to ask or say before we move on?
Do we have to draw every graph?
If the graph is given to you and you were just writing down, like if it's increasing, decreasing, or its domain and its range, then no, you do not have to draw it. But if the question specifically says graph this equation, then I need to see a rough draft of your graph on your paper, yes. Anything else for now? Okay. So then what we'll do is we will go ahead and I'll get my whiteboard up here, and we will go ahead and do the notes for section 4.6. And like I said, not going to be super lengthy. So if you have any questions, please let me know. I did already get the notes and also the homework help Hawks video that I created in Blackboard. So if you want to if you want to go along with the notes, you can do so. If you want to write them, also fine. As always, I'm going to need you to chime in if you need me, because when I make my screen the whiteboard, I sometimes can't see the chat bar. And so here we go. So this is going to be section 4.6. And in this section, what I need you to know is just a handful of things, okay? Really just 3 main things. And so like I mentioned, if you looked at the Hawks notes, they were way more lengthy, way more wordy. I've cut this down a lot, okay? So this particular section is on the inverse. Whoops, I've already spelled it wrong. The inverse of functions. And so what's going to happen is we know a lot about functions now. We know how to graph them. We know about the vertical line test. We know a whole bunch of stuff. And so now we're going to talk about inverse. And so the first thing that we want to write is this. When we talk about the inverse, we can say the word, but we also have to know how to write it. So we're going to say the inverse of f of x, which we know is just our function, is written as f with a little -1 above it, and then x. Now, we do not read this as f -1. Okay, we actually say f inverse. So this is my regular function, f of x, which we've been very familiar with. And when we talk about the inverse, we write this guy, okay, but we say f inverse. That's the first thing we need to know. Because what's about to happen is I'm going to be saying the word inverse a lot, but I'm going to be writing it out in this form rather than the word. So we got to make sure we know the notation. So any questions on this notation? That's the first thing, is what does the inverse look like? Well, it looks like this guy. And again, we never call this -1. We don't say f -1 of x. We just say f inverse. Okay, so when we first started talking about functions way back, we started talking about functions in the form of ordered pairs. So we're going to do that same exact thing. So we're going to talk about relations. And we talked way back about how when we have a relation, it is just an ordered pair. So like an XY kind of thing. And so here's what we're going to do. We're going to say, if I give you B equals, okay, and we're talking about a set of ordered pairs. So 4, -1, -3, 2, and 0, 5. So let's say this is just a set of ordered pairs, all right? Nothing special about them. They're just some numbers. Oh my goodness, I cannot make this neat. This is a 5. And so from just looking at this, I want the domain and the range. And so when we talked about the domain and the range way back, we know that the domain is just the x values and the range is just the y values. And so if this is the function that I'm given, these 3 points, what is my domain going to be? Anybody want to tell me?
All the x values.
Yeah, so 4, -3, 0. Okay, piece of cake. What's my range going to be?
The y values.
Okay, so -1, 2, and 5. Perfect. Now, here's what's going to happen, all right? We're going to take excuse me, we're going to take the idea of a relation, which is just this guy right here, but we're going to find its inverse now so that you can visually see what it looks like. So we're going to have the inverse of the relation. Okay, now, in order for me to write the inverse, I'm going to start out with B, and I'm going to put my little -1 up here so that I can read it as B inverse. I'm going to put an equal sign, and then I'm going to write some points in here. Now watch what happens. Instead of me writing 4, 1, or excuse me, 4, -1, I'm going to write -1, 4. And instead of me writing -3, 2, I'm going to write 2, -3. And then instead of me writing 0, 5, I'm going to write 5, 0. And so this is the inverse. And so now what have I done? How have I gone from my regular function to my inverse? What did I do in order to get there? Who can tell me?
Flip them.
Okay,
You
can you
switched
be-
your domain and range.
Okay, I switched my domain and range. Can you be just a teeny tiny bit more specific? Don't say the word domain and range. You're not wrong, but I want to make sure that we understand exactly how this is
Switch
happening.
the position of
You
your
made your X your Y value, and your Y
Yes.
value your X value.
Yes. So what I've done in order to find the inverse, which that was easy, right? In order for me to find the inverse, I have to switch the X and the Y. I'm going to write that down in a second. Now, someone already told me that what I've really done is I've switched my domain and my range, which is exactly correct. And so then if I'm asking for the inverse of the domain, well, I have new values, right? -1, 2, 5. And if I'm asking for the range of the inverse, I have 4, -3, and 0. And so from just looking at this, okay, without doing too terribly much work, you can see that the range and the domain, just like somebody said, have been flipped, and the domain and the range have also been flipped, so to speak. And so what I'm really saying is to find the inverse, we're going to switch the X and the Y's. That's going to be pretty much it. So before I move on and write that thing down, what are your thoughts on this page? Here's my relation. Here's the inverse of my relation. I listed out my domain and my range. I swapped them around, got my new domain and range. Any questions on this page?
No.
Okay, so now it's easy when it's ordered pairs, right? That was super easy. What we're going to have to do is we're going to have to talk about how to determine if there's an inverse, if we have a graph already drawn, or if we just have a function. So let's do a couple vocab words so that we know what's what. So here's the star sentence that we already said. We're going to say to find the inverse, because this is really important. To find inverse, switch X and Y. And that's what we just did. Okay, and everyone agreed with that. That was fine. And we were like, yep, okay, good. All right, now, the next vocab word / example that we need to look at is something that is called the horizontal line test. Now, the other day, we talked about the vertical line test, and you guys were okay with that. And so now we're going to talk about the horizontal line test. And here's what the horizontal line test says, okay? And then we'll look at it in picture form. We're going to say if every horizontal line that we could draw intersects the graph no more than once. No more than once. Then the function, and this is going to make much more sense in a picture, okay? Then the function f, which is what we're typically using, f of x, has an inverse, which we represent as f inverse, like that. And f inverse is a function as well. Okay, now again, I promise this will make more sense when we look at a picture. And then the last thing we're going to say before we do that is we're going to say that a function is what we call one-to-one, if there are no repeated y values. So I'm going to give you a second to write this down, and then we're going to talk about it, okay? So to find the inverse, switch the x and the y. We did that. That was easy. A horizontal line test. We're going to have a graph, and we're going to draw some horizontal lines. And if any horizontal line that we could possibly draw only intersects the graph one time, then the function that we have a picture of is going to have an inverse, and also the inverse that it would have that inverse itself would also be a function. If that's true, this is called a one-to-one function, which means that there are no repeated y values. So if you think back to several days ago, when we talked about the vertical line test, we said that we cannot have any repeated x values. Well, if we're taking the inverse of that, aren't we switching the x's and the y's? And then so what that leads us to is this. It leads us to this idea that we cannot have any repeated y values. Now, before we look at a picture, okay, because obviously I have to go to a new page, are there any questions on just what this says? Okay, I'm about to show you what it means, but on the words themselves. Any questions on this page? Okay, so then let's take a look at some pictures and let's make this make sense. Excuse me. All right, so here we go. We're going to have a function, let's say f of x equals the absolute value of x. Now, this is our parent function. And so in your mind, you should be able to quickly think, hey, it looks like this. You know, maybe it's a little fatter, maybe it's a little thinner, whatever, but it looks like that, okay? And so my question is this. If I gave you this function and I gave you this graph, I need to know, first of all, does it pass the horizontal line test? Well, what I'm going to do is I'm going to just pick a spot that actually is on my graph and I'm going to draw a horizontal line. Ooh, look, it's hitting twice. So this particular picture does not pass the horizontal line test. So let's write that down real quick over here. So does not pass horizontal line test. So what that means is, let's say that this is probably the point -1, 2, let's just say, I don't know. Now I guess that wouldn't be true. Let's just call it -1, 1. And let's call this the point +1, 1. And so what's happening is the reason why it's not passing the horizontal line test is because, look, I have 2 repeated y values. I can't do that. And so in this particular instance, because this guy does not pass the horizontal line test, we know that it does not have an inverse. And I'm done. So what has to happen is you have to be able to look at a picture, tell me, number 1, does it pass the horizontal line test, yes or no? Based on that answer, number 2, you have to tell me if it has an inverse, yes or no. What do you think about this particular example? Questions, problems?
I'm good.
Okay, let's look at another one then. So what if I have f of x equals x plus 2 in parentheses and the whole thing is being cubed? Well, the first thing I need to realize is that my parent function is x cubed and that my parent function looks something like this, going through the point 0, 0. Now, the transformation that's happening right here is this guy. So what is happening? What is this plus 2 telling me to do?
Left 2.
Left 2. And so if I do that, here's what my graph's going to look like. I've gone left 2, and I don't really care if it's thin or fat. Doesn't really matter. What matters is that this is my new vertex. It's going up on this side, and it's going down on that side. And that's it. There's no other transformations. And so now what has to happen is I have to draw some type of a horizontal line. Oh, hey, look, it only hits once. Okay, I'm good there. How about down here? Oh, look, it only hits once. I'm good there. How about here? Oh, hey, just once. And so no matter where or how many horizontal lines I draw in this guy, it only hits the graph one time. And so this tells me 2 things. The first thing it tells me is that it passes, I'm just going to say HLT because I'm tired of writing all that out. The horizontal line test. Passes the horizontal line test. Great. Now, number 2, because it passes the horizontal line test, that tells me that it does have an, oops, I spelled have wrong. That it does have an inverse function. So we have to be able to write that out. It does have an inverse. Oh, goodness gracious. Okay, have an INV. Does have an inverse function. And based on my answer to number 2, this function is what we call 1-to-1. And earlier I wrote out 1-to-1 in words. Another way to write that, because again, I'm lazy when it comes to words, is this guy, 1-1, like that. That means 1-to-1. So looking at this picture, can we determine that it does pass the horizontal line test, and based on that answer, that it would have an inverse? Any questions, any problems on that?
No.
Now, here's the thing. You're probably thinking, okay, fine. let's pretend for just a second that if I ask you to actually graph the inverse, remember we said to find the inverse, we switch the x's and y's. Well, my vertex isn't going to change because the vertex, well, I guess, yeah, it will. Let me go back to my parent function for just a moment. My vertex is 0, 0. That's not going to change. This might be the 0.11. I don't know. Okay. So what's going to happen when I go, I don't want to put that there. When I go to find the inverse, I'm not going to ask you to really do this, but the inverse is going to look something like this. Okay, it's going to be opposite. And so if you look over here on the left-hand side at the black line, that's my parent function. And then if you look at the red line, that's going to be my inverse function. Okay, but again, what I'm really asking you to do is over here on the right. So what are your questions? What are your problems with the graph, with the purple horizontal line test? Any issues with looking at that picture and determining whether or not it has an inverse?
No.
Okay, so that's the second type of inverse. The first one was a relation with just x and y points. The second one is a graph. Here's the third one, and this is going to be where we spend the most time. This is going to be finding inverse functions. So now what's going to happen is you're going to be given a function that's not going to be easy to graph. And instead of having to try to graph this thing, we're going to do some actual arithmetic and we're going to come up with the inverse functions formula. And that's it. So there are 4 steps and you're going to think, oh, wow, these steps are easy. And they are. It just takes practice. So here's the first step. The very first thing that we have to do is replace f of x, or maybe it's a or p or b. This letter could be different. Doesn't matter. We're going to replace our function notation with the letter y. That's going to be a piece of cake, okay? That's no problem. Step number 2, once we do that, here's where we do the inverse business. We're going to switch the x and the y location in our problem. That'll be easy. All right, step number 3. We now have to solve for the y value. This is where we're going to have to spend our work, solve for y. That's going to be the spot where we actually have to do the most work. And then once we get y by itself, step number 4, we are going to replace the y value that we just solved for with the inverse notation, which is f inverse of x. And then we're going to be done. And so step 1, easy. Step 2, piece of cake. Step 3, takes a few minutes. Step 4, piece of cake. So overall, this isn't going to be as bad as what you're probably thinking. Okay, it looks kind of messy, but this is it. And the cool part about this is we do these 4 steps for every problem. And so I have about 6 of them just in case. We may not need to do all of those, but I have lots of examples for us to go through if we need it. So looking at this chart, looking at these 4 steps, any questions on what these steps say? Because obviously we haven't had a chance to do it, but any questions on what this just says? Ask me now. Otherwise, we're going to do some problems. Okay, so then let's start out. Number 1, and let's see what this is going to look like. So you're given this function f of x, and it equals x minus 1 cubed plus 2. And I do not want you to graph this. You absolutely could because you know how, but I don't want you to. I want you to figure this out mathematically. So step number 1 is to replace this f of x with y. Well, that's going to be easy. So we'll just put y equals x minus 1 cubed plus 2, like that. Questions on 1? That was easy. Okay, so step number 2 says to switch the x and the y location in our problem. And so obviously you can see that we have a y and we have an x. And so on the next line down, I'm literally going to rewrite the problem, but I'm going to switch these 2 guys. So I'm going to have x equals parenthesis y minus 1 cubed plus 2. So this is step 1. This is step 2. All right, what do you think about step 2? All right, very straightforward, not too bad at all. Any questions on step 2?
No.
All right, now step 3, this is where we have to solve for y. So the y value that we just stuck in there, we have to get it out. And so in other words, from looking at step 2, anything that's happening to the y value right here, we have to undo and get it by itself. Okay, so we know how to solve for y because we have been solving for y for months, it seems like. And so if I need this teeny tiny y by itself, what do you want to do first in order to get that y out of there?
Subtract the 2.
Yeah, so we'll subtract 2 from both sides and we'll get x minus 2 equals y minus 1 whole thing cubed. Okay, and here's our y still stuck in there. So what do you think we should do next?
Take the cubed root.
Absolutely. So we're going to take the cube root. And again, what I do to one side, got to do to both. Now, on the left-hand side, the cube root and the cube cancel, which is exactly what I wanted to happen. On the on the left-hand side here, nothing happens. I just have the cube root of x minus 2. And that's going to equal y minus 1. Okay, now what am I going to have to do? How about just add 1? And then so what's going to happen is I'm going to be left with y equals, I'm doing two things at once. I'm swapping this and I'm adding 1 on this side over here. So I'm going to have the cube root of x plus 2. Now, when I add this 1, is it going to be added to the inside or to the outside?
Outside?
Yeah. Hold on, I accidentally wrote the wrong thing. Big surprise. Okay, so big plus 1. All right, now, for the time being, I don't really care about what this looks like. The rule was get y by itself. Did I do that? Yes. So whatever this stuff looks like, I don't care. And so the last step is to replace this y with my inverse notation. And so I'm going to write f inverse of x equals, and then I just copy this down. Cube root of x minus 2, and then a plus 1 on the outside. And after all of that work, which wasn't a ton, is maybe what you thought, here's my final answer, and I'm done. I calculated the inverse mathematically, and that's it. I'm finished. So I guess this would have been step 4. All right, so take a look from beginning to end. Tell me what you think. Tell me what you need. Tell me what you want. What's going on?
Not bad. Would we ever have to solve for the inverse?
So technically that's what we are doing by finding this y, but I think what you're doing is, are you asking me, am I ever going to have this little x equal to something?
Yeah.
No, we are not going to do that. All we're doing is getting to this step, and we're calling it done.
Okay.
Okay? All right, so what else? There was one problem totally and completely finished from start to end. Okay, so let me make sure no one's chiming in on the chat here. I don't think so. Nope. Okay. So let's go ahead then and let's do another one. Okay. And we'll see what you guys think. So here we go, number 2. And the process is going to be the same. The problem is going to look different, but we're going to do the same thing. So we're going to have g of x equals 3 over 2x plus 1, like this, plus 1. And then, of course, I'm trying to find, at the end, the inverse. And so step 1, rewrite this as y. Okay, that's easy. Step 2, switch the x and the y's location. So this will become x equals 3 over 2y plus 1. So here's step 1, here's step 2. Okay, step 3, I have to solve for y. So I have to get this teeny tiny y all by itself. And so what do you think I'm going to have to do in order for that to happen? Someone tell me what you would do.
Multiply by 3?
I can't multiply by 3 because 3 is in the top.
Okay.
How do I get rid of a fraction, generally speaking, when I don't want a fraction? I multiply by its
Reciprocal.
not reciprocal. How about
Denominator.
denominator? Yeah. So I'm going to have to multiply both sides by 2y plus 1. So I'm going to multiply this by 2y plus 1. Now, when I'm doing multiplication over here on the left-hand side, and I have two things, what's that way that I do my multiplication? When I draw these arrows, what's that called? It starts with a D, distribute. So on the left-hand side, I'm going to say, okay, well, what is 2y times x? Well, it's 2yx. And then what is 1 times x? Well, it's plus x. And then on the left-hand side, or on the right-hand side, excuse me, the 2y plus 1 times the 2y plus 1 cancels, and it leaves me with 3, which is exactly what I needed. Okay, well, my y is stuck here. It looks even worse, kind of, but we'll get to it. So the next thing I want to do is subtract x from both sides. And that's going to leave me with 2yx equals 3 minus x. Now, when you take a look at y there on the left-hand side, what's happening to y? It's being what? Multiplied by
2 and x.
2 and x, not y and x, because I'm trying to get y
Yeah.
by. So you don't have to apologize. You're totally fine. Okay, so in order for me to get rid of this 2 and this x, I'm going to have to divide. And I think I'm probably going to run out of space here. I'm dividing both sides by 2x. And then so what's going to happen is that's going to leave me with y equals 3 minus x over 2x. Now, over here on the left-hand or on the right-hand side where this fraction junk is, remember, I don't care about that. I don't really care what it looks like at all. I don't want you to try to factor none of that junk. Hey, you got y by itself. That's what you were supposed to do. So we're done. And so then step 4, lastly, is I have to take this y value and I have to replace it with the inverse value. So I'm going to have g inverse of x equals 3 minus x on top and 2x on the bottom. And this is my final answer. Done. All right, so there's a second problem. The problem started out a little differently. What are your thoughts? Any questions, any problems? Okay. Let's see. Okay. I want to take a look at one that's going to scare you until I show you how to fix it. So here we go, number 3. We're going to have g of x equals parenthesis 2x minus 1 close parenthesis, and this whole entire thing is going to be raised to the 1/3. And this is what scares everyone because you see this fraction, right? Okay, well, we're going to take a little sidebar here for just a sec. Maybe, but I think I hit the wrong button. That wouldn't surprise me. Okay, so we're going to do a little sidebar here for just a minute. A long, long time ago, we had mentioned very briefly that if we had x to the 1/2, we don't really know how to deal with fractions that are exponents. Does anybody remember what this is equivalent to? That is something that's much more common that I use a lot. Anybody remember? Okay, well, we had said that if we have a fraction as an exponent, we put this little guy on the outside of the square root symbol, and we put this little guy on the inside. Remember us doing that a long time ago? And this is where we get the square root of x from. And so regardless of what number's on top and what number's on bottom, the bottom number always goes outside and the top number always goes inside. And so if I'm given this big old nasty 1/3 of a fraction and I don't want that, how can I turn this 1/3 stuff into something with a radical symbol? What am I going to have to do?
Cubed root.
Yeah, that's it. That's exactly it. So before I do anything else, let me do 2 things at once. Let me rewrite this as y. And instead of writing all this junk out as it is, let's go ahead and make it the cube root because I know I'm going to need that. And so let me do that. Oops. Hold on. I'm having an issue with my pen here. Okay. So let me go ahead and write it out as the cube root of, and then I'll have 2x minus 1, like that. And so now this big old scary fraction gone. Don't even care about it. So before I go any further, what are your thoughts on that? Because that's going to become a big part. Is can you take this fraction and rewrite it as a square root of some sort? Are there any issues or problems with that? Because we're going to see that again for sure.
So you could do that with like any number, like the number doesn't matter. So like
Yeah, it could be like 1/2. That would become the square root.
okay.
It could be like 1/6, then that would become the 6th root. Absolutely. It's not going to matter what the number is. Okay. It could even be like 2/3. That would still be okay. All right. So here we go. So we've done step 1. We've rewritten it as with y. Step 2 is to take the x and the y and swap their locations. So this is going to turn into x equals the cube root of 2y minus 1, like that. Okay, well, in order for me to get this y value out of here, how in the world am I going to uncube root something?
Maybe by cubing it.
Absolutely by cubing it. So what I do to one side, I have to do to both sides. And so that's going to give me x to the 3rd. And then since I'm cubing all of this, the cube root and the cube cancel, and that leaves me with 2y minus 1. Okay, so now it looks much better because now I don't have any nasty old square roots or any old nasty fractions. And so what's going to have to happen next in order for me to get this y value by itself?
Add 1.
Add 1 to both sides. So that's going to give me x to the 3rd plus 1 equals 2y. Okay, now what?
Divide by 2.
Divide by 2. Excellent. And so now I'm doing 2 things. I'm flipping it and I'm just going to rewrite it. So x to the 3rd plus 1 over 2. Now again, I don't care about what this right-hand side looks like. Do I have y by itself?
Yeah.
Yeah, and that's what I wanted. And so now I'm going to take this y out of here, and I'm going to replace it with the inverse. So g inverse of x equals x to the 3rd plus 1 divided by 2. And here is my final answer, and now I'm done. All right, what do you think about this one? Not so bad, right?
No,
Okay.
not bad.
It's not bad. Okay, so I'm going to show you one more, and then I'm going to ask you to do one without me, just to see. Okay, see how it goes. So number 4, we're going to have p of x equals 3 and then cube root of x. And on the outside is a minus 4. Ooh, boy, this one looks rough, doesn't it? Lots of things happening. Okay, well, first things first, let's rewrite this as y. Okay, nothing else over here for the time being. It's going to change. And then next, I need to take my x and my y and swap their locations. So this will become x equals 3 cube root of y minus 4. Okay, now, what do you think should come next?
Add your 4.
Yes, let's add that 4 to both sides. And so I will get x plus 4 equals 3 cube root of y. Okay, now what?
Get rid of your 3 on the outside.
Okay,
Just
I'm
add the
not,
three.
I can't tell exactly who said that, but that's true. I want to pause for 1 second. A lot of people here want to try to cube this, and they want to try to cube the whole thing. We can't do that because between this number 3 and this square root symbol or this cube root symbol is a multiplication. So the only thing that's actually being cube rooted is just this y value. So to whomever said get rid of your 3 on the outside, that is correct. How am I going to get rid of this 3 that's on the outside?
Divide it.
Divide, yes. So I will divide, and so now I'm gonna be left with the cube root of y. I'm swapping its. I'm just flipping the way that looks. Equals x plus 4 over 3. Okay, good. And what's the last thing I'm gonna have to do here to get y by itself?
Cube both.
Cube both sides, yeah. And so on the left-hand side, the cube root and the cube will cancel. That'll give me y equals. I have x plus 4 over 3. The whole thing is cubed. And again, over here on this left-hand side, I keep saying left, but I mean right. Don't try to be foiling all this junk out, okay? I don't care what it looks like. Leave it. And so finally, I ask you, do I have y by itself? Yes, I do. And so I replace that with the inverse. So I have p inverse of x equals x plus 4 over 3, whole thing cubed. And this is my final answer. Done. Better?
Mhm.
All right, you guys want to try one without me?
Mhm.
You make
Yeah.
it easy or hard?
Kind of hard, kind of
Woo,
like in
okay.
between.
I'll give you a tougher one just to see, okay? Because you're going to be doing these without me. And so when I say hard, I don't really mean that. Just, we'll see. Okay, so here you go. Here's the one I want you to do. So a of x equals 2x to the 5th minus 9 over negative 2. Now, I learned the other day by mistake that a student, so any of you guys, can actually write on this whiteboard. So someone do me a favor and just draw something on the whiteboard to see if it's actually going to work. I don't care what it is. Someone just use your finger, draw something, and see what you get. Is it working?
No.
Oh, someone wrote hi.
How do
Does
you
everyone
I don't know
see
how to
that
do
red hi? Hi?
How did they do that?
I don't know. My
I have
guess
no
is
idea.
I don't know how they did it because all I can see is what is my point of view.
So
And
if you
I-
go up to the top of the screen and it says you are viewing Amanda Smith's screen, and then you go to view options in that down menu and then do annotate.
Ah, okay.
Oh.
Does that make sense to
Yeah.
you guys?
Okay, so here's what
Yeah.
I want us
Okay.
to do, okay? If you're writing, I appreciate it. Look at you guys. Okay, go ahead and clear all of your writing. And you guys as a class, I don't care, somebody or more than one people, I want you guys to solve this problem on this whiteboard. You guys can talk. You guys can pick one person to write. I don't care. But I'm just going to sit here and watch. So I'm going to clear all of your drawings. And you're going to start this problem from start to finish. And you guys are going to talk together, figure this out, write it down. Okay, so I'm going to sit here. Go ahead. Yeah, you guys killing it. All right, guys. Here we go. Go ahead, please.
You replace
Um,
x with y.
So someone has to write it down too, because I'm not writing anything. I want to see everything that you guys do. Okay, good.
Then replace it with x.
Oh, why is it so light?
I don't know. See, it's a little harder to write on this than you think, huh? That's why my
Yes.
writing sucks most of the time. Okay, so you did step 1, and we're working on step 2.
So why don't you take everything times the -2?
Well,
Yeah,
when you
hold
put it,
on 1 second
both
because the
sides.
person's not finished yet.
Okay.
Okay, good. So now someone says, don't we have to multiply everything by -2? Yes. Okay, so we're gonna have to do both sides. So someone do that for me. Multiply both sides by -2. Okay, good. Okay. So then what's gonna happen on the left-hand side?
It's going to become -2x.
Yes, it is. And what's gonna happen on the right-hand side? Yep, that's gonna cancel. Perfect. Okay, great. Now what?
Add your 9.
Okay. Okay, I'll do that since no one else is. So plus my 9. So I have -2x plus 9 equals 2y to the 5th. Okay, now what?
Divide.
Okay, divide what?
Divide by 2.
Okay, so we'll do that. Okay, so you're dividing by 2. Okay, keep going. Perfect.
You're
then
going to
so-
get y equals -2x plus 9 over 2.
Well, hold on. We're not just going to get y. We still have this
Y
guy.
to the 5th.
So let me write that with my pen since it's a little bit smaller, okay?
Yeah.
-2 over 2. So here's what I have, okay? Let me get rid of some of this blue stuff, maybe. So I'm left with y to the 5th equals -2x plus 9 over 2. And so what's the last thing I'm going to have to do here?
Times by.
Couldn't you do like the root of 5 maybe?
Yeah, the 5th root. So I'm going to take the 5th root of both sides. And so on the left-hand side, the 5th and the root cancel. And that leaves me with, and now this guy's ugly, okay? But again, I don't care what it looks like, right? All I care about is that I have y by itself. Do I have y by itself?
Yeah.
Sure do. And so I'm going to come over here and just erase some of this, but everything that we've done so far has been perfect. Thank you. And just write that my A inverse of X equals, and then I write this whole big nasty thing. And again, I don't care what it looks like, which is nice because sometimes I do. Okay. And so here's my answer. A inverse of X equals the 5th root of -2x plus 9 divided by 2. Done. Completely and totally done. All right, what do you guys think? You guys are killing it. Any questions? Any problems?
Is that X ever going to be a number?
Right here in this center?
Yeah.
When we get to the next unit, which is going to be chapter 7, it's all about inverse functions, so it eventually will, but for this day and this test, no, it will not be. Now, one other thing I want to add, when you're working in Hawks, the questions are going to ask you, they're going to give you a function that looks like this probably, and they're going to ask you, hey, if this has an inverse function, go ahead and find it. And so what you're going to see is you're going to see your function up here, and they're going to see a box right here, and they're going to see a little button that says no inverse or something like that. And you're either going to write, P of X inverse equals blah, 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 or you're going to click right here. I'm telling you right now, your question's always going to have an inverse. You're not going to choose this. Now, I do want to show you what it would look like if you were given a function that doesn't have an inverse, just so you understand. All right, so let's pretend this is the function I'm giving you, and we're trying to find the inverse. Okay, so we're going to say, all right, well, y equals the absolute value of x. We're going to swap these guys around, and we're going to solve for y. Now, this one's a little tricky because we have to think way, way back to when we first started talking about absolute value. Generally speaking, just generally speaking, what is the absolute value of y? Well, it could be y or it could be negative y. Do you agree to that? Do you agree that if I put a positive y in there, its absolute value is y, or if I put a negative y in there, they have the same absolute value? Do you agree to that, guys?
Yeah.
So if you look back to our definition, okay, way, way back, it specifically said, today's definition rather, we could not have any repeated y values. And so what's going to happen is if I choose an x and I stick it in here to this, or if I stick the y in the absolute value symbols, it's either going to give me a positive or a negative. And so what that tells me, you already know that my parent function looks like this. We already discussed how when we draw a picture, it doesn't pass the horizontal line test. So this guy does not have an inverse. Well, here's why. Because if I were to complete this problem, I could technically have two answers. And I am not allowed to have two repeated y values. So the problems that you see in Hawks, they're all going to have inverses. Okay, it's set up that way. But this is what it would look like if they didn't. And I want you to understand the difference so you're not just like, well, Amanda said it has to be true. Okay, I want you to, I like you to know the why behind it. Okay, should I let you guys try one more, or are we done, or what do you guys want?
If
think
there's
about-
another type of one that you could think of besides like the cubes.
There's
like the
not
square
there's
root.
not going to be another type. There's either going to be the fraction, there's going to be like a cube root, there's going to be one where you have to turn a fraction into a cube root, and then there's just going to be a normal fraction like the one we just did. So those are the main types of problems that you're going to see. So I definitely picked several of
Okay.
each. But other than that, it's just going to be different numbers, and it's just the same thing over and over and over.
Can we do another one with the fraction as the exponent? Like
Sure.
example 3?
Okay, so let's see. So what if we have f of x equals, and then we'll have like a 3x plus 2, let's say, and let's raise it to the 1/5. How about that?
Cool.
And so what's going to happen is, we know that we're going to make this say y equals. How am I going to get rid of this fraction as a 1/5? I'm going to turn it into what?
5th root.
Exactly, the 5th root. Okay, perfect. And then I'm going to swap my x and my y. And then I'm going to have to solve for y. And in order for me to get rid of the 5th root, I have to raise it to the
5th.
And so whatever I do to one side, I have to do to both. And so that's going to give me x to the 5th equals. Over here, the root and the 5th will cancel, leaving me with 3y plus 2. And then from here, I'm going to subtract 2. And so I'll get x to the 5th minus 2 equals 3y. And then I'm just going to divide by 3. And so I will have y equals x to the 5th minus 2 over 3. And I say, hey, look, got y all by itself. Don't care about what anything else looks like. I bring in my inverse notation, and I say that the inverse of x is x to the 5th minus 2 over 3. And here's my final answer. Better?
Yeah.
All right, anything else that you guys can think of while we're right here, right now?
Is it possible that the fraction would ever be like 2/5 and we'd have to distribute the 2 into the bottom?
Okay, so for our sake, the answer to that is no. But what you're saying is, could this ever be a 2/5? Sure. So then what would happen is this guy down here would be squared. And so what would have to happen is you would have to FOIL all of this. It's a mess. And so that's why for our sake, it's not going to be.
Okay, so it's
Okay.
possible, but we won't encounter.
Sure, it's absolutely possible. Because I mean, if that were true, we know how to FOIL, right? And then we just come back and we'd FOIL. It would take forever, but we could do it. And so for our sake, it's just going to be a 1 on the top. Okay, because we only know, we really only know how to deal with the square root, the cube root, things like that. We don't know how to deal with something that's being squared under there, okay?
Mhm.
All right, anything else that you guys can think of? I went through the Hawks homework, the video is already made, and so I looked at the homework that they're gonna ask you to do, and I feel like we've covered it really well right here. So if you don't have any other questions, then I'm good as far as the notes go.
That's it?
That's it. That was this
Oh.
section, yeah. This was
I
the
was waiting
shortest
for like
part of the-
another,
Pardon me?
I was waiting for like another section.
No, that's it. That's it. So let me get myself, let's see, I don't want to share the whiteboard anymore. So that is all as far as this section goes. So that's it. So I think that 4.6 is probably going to be the easiest one. It's definitely the shortest. And so, I mean, I'm good. As I mentioned prior to the meeting, some of us were asking over here in the chat bar, we are going to review tomorrow. And like I said, just for anyone who was coming in a few minutes late, the review, the Unit 4 review, as well as the Unit 4 review key and the formula sheet and an old test is in Blackboard for you under Unit 4, and then at the bottom where it says review stuff. And yesterday, some of the ladies who I was speaking with, I tried to show you guys where those extra worksheets are, and I forgot. It's in the review section. So if you click on the review folder under Unit 4, you're going to see some folder or some worksheets with some blank questions and some answer keys, and they're specifically targeted to hit some of the things that I know we're struggling with. So if you guys are good, I'm good. And so if you guys do not need me anymore, you're good to go. You can leave.
Is
Some of
the
us-
I'm sorry. Is the worksheet due tomorrow night?
The 8th, yeah. Okay.
Okay.
Okay, Rebecca, looks like you're raising your hand. You're good. Okay. So yeah, if you guys want to stay and talk to me, please stay. I know some of you had questions. If you want to go, go. That's it. So I'll give you a second to check in, check out. You're welcome, Shelby. Have a good day too. And then if you guys want to hang back and talk with me, please do. Otherwise, I will see you tomorrow.
Hey.